Hi, I'm Jace with RMUS. Welcome to this Tech Connect today, and this one's a little bit unique. I actually have a guest with me today. It's Kieran Boyd with Avestec. Kieran, why don't you tell us a little bit about yourself and what you do with Skyron?
Sure. Well, thanks for having us. I am the marketing manager at Avestec. I'm from Vancouver, BC, Canada. I work on creating the content, strategy, and outgoing communication for the company. I work on sharing our growing business and products with our market.
Gotcha. Cool. So the reason we have you on today is we're kind of gonna start talking about the Skyron specifically. You guys have a very unique platform. So let's talk about the aircraft. But first, to give our viewers an introduction, we're gonna watch this video. So Kieran, as our viewers saw from that video just now, the Skyron is a unique aircraft in that it's actually designed to touch things instead of avoid them. Obviously, contrary to most of what people want to do when they're flying an aircraft. So, can you give us a breakdown of what Skyron is actually doing? What's it designed to do?
For sure. The Skyron is designed to make in the inspection service job more efficient and more safe. Our flying robot takes the secure approach by attaching itself to the asset in preparation before using its onboard abilities.
Right. So what are we actually doing when we're attaching to these units, devices, whatever you want to call it? Lots of tanks or even ship hulls, stuff like that. What are we actually doing?
Right. So for the contact-based inspection, which is one of the abilities of Skyron, when we attach to an asset, like you said, tank, we are taking UT ultrasonic measurements of said asset. And so with that, we can tell the thickness of the asset and see if it's in the proper shape that the asset owners and NDT inspectors expect it to be.
Right. So, yeah, doing measurements of thicknesses. I mean, inspections, and obviously safety. It seems like is what that's designed for. So, Avestec has kind of adopted this fly, attach, measure model. Is what I see a lot. And give us a little more in depth, kind of a step by step on how this process works. Like you mentioned the actual sensor itself. What's actually happening when you're doing a measurement, and then where do you go from there?
Sure. So the fly attach measure model is based on providing the most accurate NDT results as possible. It starts when the inspector and the pilot are set up and they take the Skyron off for flight. At that point, it goes from 0 to 100 meters to reach the desired measurement point. When it reaches that point, it uses the robotic arm to lock onto the asset. The asset's surface can be angular or curved, and the robotic arm rotates or confirms to the surfaces. At this point, the Skyron is secured and set to measure. Now, the measurement phase of Skyron is both the preparation for measurement and the measurement itself. In the preparation, it uses the electronic brush to remove any potential debris that may obstruct the readings. And then it uses the couplant gel dispenser to dispense couplant gel to ensure that the reading is between the UT probe and the asset, respectively. Now, at that point, when the measurement is prepared, the UT probe reaches out and makes contact with the asset. The UT probe is able to move within a 2x2 window thanks to the robotic arm. So it can move anywhere and take multiple measurements within 2x2 inches. After the measurements are suffice, the arm detaches and then it flies, attach, and measures on the next desired measurement point, thus repeating that process.
Gotcha. And actually, it's funny you say that. That's actually one of my favorite things about this aircraft. Maybe it sounds a little corny, and you probably hear that all the time, but I love the idea of these manufacturers kind of pushing the limits on what they're capable of. I mean, a brush that actually cleans a surface and then attaching a coupling gel. I love to see that kind of stuff. So moving on just a little bit though, can you tell us a bit more about the different models? Because there are a couple different models of the Skyron. There's the VMS 53, the USC 53, and they have different purposes. Can you tell us a little bit about, what the purpose of each of these aircraft is, what their specialty is?
For sure. So the Skyron has a modular system that has both the VMSC and the USC 53. They are the visual and ultrasonic payloads, respectively, and they are modular systems of each other. So the visual payload is our gimbal, and the ultrasonic is the robotic arm. The robotic arm is the one that's involved with the fly, attach, and measure process, whereas the gimbal carries a Sony A7 camera and can rotate 180 degrees vertically. The gimbal is used for close and general visual inspection in open or confined spaces. Both payloads are interchangeable on our Skyron platform, so we are able to remove one and replace the other within minutes. I
Gotcha.
should
So you
note,
don't, yeah, so you don't necessarily have to buy two aircraft. You can swap the payloads.
yeah, so you buy one aircraft and it comes with both a visual and a ultrasonic payload, and you can use both interchangeably. And I should note that the ultrasonic, the Skyron UT payload, has a visual camera which can be used for visual inspection while you're conducting a UT measurement.
Gotcha. It just may not necessarily be optimized for something like that, but different tool. We always say there's a different tool for a different purpose. There's not always a one size fits all. It's a toolbox, right?
Absolutely.
Um, and let's not forget about the tether system as well.
Yeah, so the tether system powers the drone so it has unlimited flight time, and it also takes the data back that the UT gauge is providing and stores that in a local area network on it.
Right, and that kind of leads us into the next thing, is that there's some real-time capability for looking at these measurements, but also what else can you talk about with the software solutions? Once the data is captured, what
Mhm.
does the ecosystem look like from, capturing the data, logging the data, and analyzation and reporting? One of the most important things is, what does that process look like?
Totally. Well, so for our software solution, we have an in-ware software called Avisoft, which allows us to remotely operate and collect data over our wireless local area network, again, that is hosted by our smart tether system. So in operation, a primary report is immediately prepared right after, and the collected data is then stored on that local area network. At that point, the A scans, images, spatial measurements, etc., they're all accessible for the inspector. From there, the inspector can analyze and make a report using Avisoft.
Gotcha. Awesome. I mean, it sounds like a very efficient, very effective workflow. And then, kind of finally, we're getting close to the end here, but a lot of the question is, who is the Skyron best suited to serve? I mean, what kind of users are you finding that Skyron has been the most useful for? Who's actually using this in the field?
Yeah, so we've been used and widely validated by various owners in both offshore and offshore. It's been commercially proven and ready to adopt by many NDT service inspectors and asset owners. So I think it's just best suited for those two parties, inspectors, inspecting services, and asset owners.
Sure. And as always, it seems like that's the moniker of pretty much anything we do with an aircraft or any other unmanned system that we have here, is the whole point of this is to get people out of harm's way, right? I mean, inspecting this kind of stuff can be highly risky. And it seems like that's part of the thing that Avestec and Skyron is trying to do, is, getting people out of harm's way. Is that fair to say?
Exactly. That's our goal. It's making it safer and more efficient. But the main priority is just keeping inspectors and pilots from the distance they deem and that is acceptable, that is safe. And they can just put the robot up there, get it to do the job at the heights, come back down.
Yeah, definitely. Again, it seems like that's the story of pretty much everything here we do at RMUS. So that's going to take us to about the end of this video. Kieran, I want to thank you so much for joining us today. And again, this is very surface level, just kind of what is Skyron, what can it do for you, and introducing our customers to this thing. I'm sure we're going to have more content for you in the future. Is there anything else that you'd like to leave us with?
No, I think, like you said, we covered the surface level stuff. If anybody's interested in more, or has any questions, they know where to go. And I also want to thank you, Jace, for hosting us today.
Yeah, hey, again, thank you so much for joining us. I'm really glad you're able to do it. And again, I'm sure this won't be the last that you hear from RMUS and Avestec about the Skyron. We definitely want to dig our claws into this a little farther and go a little more in depth. So thanks again for joining us, and for the viewers, I hope you enjoyed this content. Make sure you reach out to RMUS if you need additional info or quoting, and we'll make sure we get those questions answered for you. Thanks again.